But strictly speaking, in our case, it is Docker. Everywhere the Docker is being used mostly. So by this time, you must be understanding what is Docker, what is Docker image, what is container, what was the problem that industry was facing before the concept of containers. So all these things we have seen in the Docker process, and I hope all of you have understanding about the Docker containers, how to containerize various kinds of application, say Node.js, Java, Python, and other applications. Yeah, somebody is raising their hands. Voice not getting properly, must be getting. So this Kubernetes course will last for 2 weeks. It will start tomorrow at 7 a.m. The class duration will be of 1 hour 15 minutes, and duration is Kubernetes duration 2 weeks. 2 weeks, or you can say 14 days. Class timings 7 a.m. to 8:15 a.m. Monday to Saturday. Okay, so this is brief about the class. Now, coming to course content, what are the things that we are going to cover in this course? Introduction to the Kubernetes, various components in the Kubernetes, Kubernetes architecture, GTCD cluster, Kube API server, Kube controller manager, Kube scheduler, kubelet, kube proxy, parts with YAML, replica sets, deployments, services, namespaces, imperative versus declarative deployment approaches, kubectl apply command, scheduling. We will see many commands, but kubectl apply command, what is happening when we are running this command, we will see and experience that. Scheduling of the pods on various nodes, manual scheduling, labels and selectors, times and toleration, node selectors, node affinity, resource requirements elements, daemon sets, logging and monitoring, application lifecycle management, rolling updates and rollbacks, commands and arguments, environment variables, config map, secrets, scaling application, multi-container pods, init containers, cluster maintenance, role-based access controls, cluster rules and role bindings, service accounts, storage volumes, PVCs, storage clauses, networking, container networking interface, ingress, deploy a Kubernetes cluster with kubeadm. We will design our own Kubernetes cluster with kubeadm tool, whether in AWS or Azure cloud, whatever is possible. Then we will also see managed Kubernetes service, that is Elastic Kubernetes service and Azure Kubernetes service. Finally, we will conclude. Okay, this is briefly what the course content look like. It is open-ended. Okay, so let me dwell into the actual lecture. By this time, you must be understanding that what is container. Container is a running instance of a Docker image in our case. Container is a running instance of a Docker image. Let me briefly introduce these terms if you are not aware. ELK also, we will deploy ELK, but that is one thing we will see. Docker image. Docker image is nothing but the package of application along with the dependencies. When this Docker image comes into running state, then it is called as the container, as simple as that. This all Docker images will be stored in the container registries, that is hub.docker.com, and organizations will have their own private registries like Azure Container Registry, and if it is AWS, then you will be having Elastic Container Registry. So I assume that you have the knowledge of the containers. Now, coming to this Kubernetes, what is Kubernetes? What is its name? Why we are going to learn it? Kubernetes is an open source container orchestration platform. Docker is a containerization tool. It means using Docker, we create the containers. Then using Kubernetes, what we do using Kubernetes, we orchestrate the containers. So Kubernetes is a container orchestration platform. What is container orchestration? It is the process of automating the deployment of containers, management of containers, scaling of containers based on the traffic, and the networking of the containers in a distributed environment. Distributed environment here in the sense you will be having the multiple machines. In those multiple machines, the deployment, management, scaling, and networking of the containers will happen in an automated fashion. That is called as the orchestration. So this Kubernetes is a container orchestration platform that automates the deployment, management, scaling, and networking of the containers. Then, who developed the Kubernetes? It was developed by Google using Go programming language, and it became open source since 2014. Means in order to use the Kubernetes, you no need to pay the payment. So as I said, you should be familiar with the Linux terminal, and Docker is a must. Okay, so why Kubernetes came into picture when we have the Docker? Docker, using Docker, we can create the containers, we can containerize, or we can Dockerize various kinds of applications. Then what is the role of Kubernetes? Why after learning Docker, we need to learn the Kubernetes? Let me take you to that context. Let's suppose that, let's suppose that a person or a business entity is having an hardware, a hardware it is having. This is called as the infrastructure in general. This is called as what? Infrastructure or hardware. With a specific size, let's say a RAM of 20 GB. Okay, a memory of 20 GB. Then it will be having some operating system called host operating system. Host operating system. Let me quickly tell you the context why we need to go for the Kubernetes. That's what I'm trying to tell. This is called as the host operating system. What we do is, in order to containerize the application, in order to run the container, we should have the container runtime installed in this host operating system. That is container runtime. In our case, it's called Docker. Docker engine. With this Docker engine, we will be able to create the containers for an application. Let's say application 1 is running here. It's a container. Okay, it's a container. What happens is that this is the host operating system. We have the service running within this container. At the initial phase of the particular business entity, this container can able to withstand the traffic, because there will be few customers which will be hitting this particular service. In that case, this container will be successfully able to handle the traffic which is coming from the outside. Then what happens? The business keeps on growing, as the business is expanding, what happens is that the customers will grow. In that case, this single container cannot handle the traffic. Let's say mention there are only 50 customers. This container can serve the 50 customers without any service interruption or without any downtime. But as the business grows, the number of customers which are hitting the particular service, let's say e-commerce service, let's assume that Flipkart service, flipkart.com is our service at our interest. When the Flipkart was doubled, definitely there will be one or two customers, and day by day it will be growing. So in order to handle the more requests, we will replicate the service. Means the same application will be running here as well, this container as well. The same application will be running, but it is running two times. Here it is running, here it is running. So that instantly, if this container is able to handle 100 requests, and the container will also handle 100 more requests. In that case, what is happening? We have expanded the capacity of the service. Then let's imagine what happens if the thousands of customers are hitting our service. Definitely, we have to scale this. And scale this, the particular, whatever the particular host mission where these containers are running, that may not withstand the containers, multiple containers, right? It will be having some capacity, and beyond that capacity, we cannot launch the containers. In that case, and that is one thing. And what happens? The entire hardware fails. The entire hardware fails, or let's come from inside. What happens if this second instance fails? If the second instance fails, it doesn't mean that the request will be less. Still, people will be hitting the service. In that case, there will be downtime because the requests are 200 requests are coming, but this container will be able to handle only 100 requests, and we are assuming that this container is crashed. In that case, there will be a downtime. Only 100 people, 100 requests will be served with this container. And what about the other 100 customers? Definitely, it will be a huge loss to the business. In that case, we should have a high availability servers. In that means, even if this container fails, in its place, a new container has to be created in an automated fashion without doing any manual intervention. What I'm telling is, when this container crashes, in its place, a new container has to be created that has to serve the requests that are coming to the particular service. Then only it will be fruitful. That's fine. Now, in its place, we have created a container. For that, Kubernetes will does that job. It will automate the deployment and replicates the process based on some conditions that we will set, whether that can be of CPU or memory. Let's suppose that if the memory is crossing 70%, let's suppose we will define in the Kubernetes YAML files that we have to create another container. And even if a particular container is failed, then automatically in its place, a new container has to be created. That Kubernetes does the job. Okay, let's suppose, okay, in its place, a new container is created and it will solve the request. What if the entire infrastructure goes down? There may be situations, right? What if this entire infrastructure goes down? Could you please wait a moment? What if entire infrastructure goes down? There has to be a mechanism where the service should not be disturbed. What happens in this case? We have one host machine, but we have multiple replicas. We have taken care that when the container is failed, automatically a new container will be created. This can be achieved with the Kubernetes. Then what Kubernetes will also do is, what let's assume, what if the entire host machine fails? The entire Flipkart application will go bankrupt, and the application will not be running, leading to absolute downtime. In that case, it will be a very huge loss to the Flipkart website or a business entity that is running some e-commerce website, right? So in this case, we should have a mechanism. We should have a mechanism where even if this entire machine is failed, even if the entire server is failed, there should be an automatic mechanism where this entire setup will be created. Entire setup will be created. Hardware will be there. In that hardware, automatically this container runtime has to be created, and whatever the pods that are serving our request earlier before this failure has to be created here, and they have to serve the request without any time. We thought earlier, we said we should have the two replicas, two instances of the particular application. So even if the entire infrastructure breaks, we should have a mechanism within no time. A new machine has to be pop up and it will serve the request. This is what the Kubernetes does. So now let's go to the Kubernetes documentation. Let's close this. As I said, Kubernetes is a container orchestration platform. Orchestration means automating the deployment of containers, management of containers. Management here sense, we may tell that we need to have two instances of the particular application. Means the particular application has to be run in two containers. For what? Even if the one container fails, other container has to serve the request, or the number of customers are increasing, the two container has to distribute the load among themselves. Okay, that is called as the management and scaling of the containers. Whenever the number of customers are increasing, automatically new containers has to be created. Okay, and those containers has to be networked in order to access them smoothly. That is what. So what is Kubernetes architecture? In the world of Kubernetes, a node can be either a physical or a virtual machine. Kubernetes contains a cluster of nodes. A node can be a physical or a virtual machine with a given role. What the role? These nodes will play, we will see. Okay. A collection of such machines or servers using a shared network to communicate between each other is called as a cluster. What we have seen, we will be deploying the containers in a distributed environment. Distributed environment means we will be having multiple machines. Either they can be virtual machines or they can be physical machines. The containers will be launched in this distributed environment. In this distributed environment, containers will be launched, and containers will be launched in this distributed environment. In this fashion, and all these containers should be able to communicate with each other, and these containers should be deployed automatically, and all these things, all these nodes will be connected to each other through networking rules. That is what. In this fashion, we will deploy the containers in a distributed environment. Then, so all these machines together is called as a cluster. So we always refer to Kubernetes cluster. Cluster means a group of machines. So a collection of such machines or servers using a shared network to communicate between each other is called as a cluster. So now let's understand the Kubernetes architecture. Kubernetes architecture means what the Kubernetes is made up of. It is made up of various nodes and what are the roles of the nodes. We will see that. Now let's copy this to a paint. I don't know if it is copied or not, no problem. Okay, the Kubernetes architecture, let us see. Kubernetes architecture. As I said, Kubernetes is a cluster of nodes. In this, we will be having control plane, which will act as the manager, and we will be having the nodes. These nodes will be acting as the workers. Okay, this is what is called. This is called as the control plane. Control plane are the master. These are called what? Nodes. Let's say this is node 1. This is node 2. What are the roles of this control plane and the nodes? Control plane consists of Kube API server. Control plane consists of Kube API server, Kube API server, etcd, scheduler, Kube API server, etcd, scheduler, Kube API server, etcd. One more component that we have. Yes, controller manager. Controller manager. Let's see what are the different nodes in this Kubernetes cluster. Later I will explain each and everything clearly. So these are the control plane components. What does master contain? Master contains Kube API server, etcd, scheduler, controller manager. If you are using the manager Kubernetes, then we will be having the cloud controller manager as well. And node contains container runtime. First kubelet it will contain container runtime. In our case, it is Docker and kube proxy. These are the components of the nodes. Here also kubelet. We can have hundreds of nodes also. Each node will contain these things. Kube proxy. Okay, these are. In Kubernetes, we will have control plane and the nodes. Control plane will act as the master. Master means it is the whole responsibility of the master to take care of the entire Kubernetes cluster. The entire Kubernetes data will be stored in the etcd, and we will see one by one what these components is all about. And how do we interact with this Kubernetes cluster? One is through kubectl command line. What is the kubectl command line? Kubectl. With this, user will interact with the Kubernetes cluster. Okay. So let's see what every component of the Kubernetes means is what they do. This is, we can interact with the Kubernetes cluster through user interface and kubectl. Mostly we will use the kubectl only. Okay. So control plane and the node. Control plane makes most of the necessary decision and acts as a sort of the brain of the entire cluster. This can be a single server or a group of server in larger projects. Okay. In larger projects, we can have multiple masters as well. Okay. Multiple nodes we will be having to execute the loads. They will take the load. All these nodes will be take the load. Master won't take any node. Instead, master will manage the Kubernetes cluster. Okay. Then a node is responsible for running workloads. What are the workloads here? Mainly the containers. The containers will be run inside the node zoning. If you can observe in interview, they will ask, does the Kubernetes master contain Docker? No, Kubernetes master won't contain the Docker. Only the nodes will be containing the Docker, that is container runtime. That is one of the point. And these servers are usually micromanaged by the control plane and carries out various tasks following supplied instructions. We will see what the node will contain. Whenever we are running a command to create the Nginx containers, whatever the containers will be created using this command will be created on the nodes only. But master is responsible to create nodes in the to create containers in the nodes. We will see each component, the functional each component. So mainly in Kubernetes cluster consists of 5 components: server, APIs, to the Kubernetes control plane, responsible for validating and processing requests delivered using client libraries like kubectl program. Whenever we are running a kubectl command, this request will go to kube API server. Whatever the command that we will run, whether it can be run command, describe command, and delete command, and ls command, whatever the command, create command, whatever the commands that we run using the kubectl, that command will first goes to the kube API server. Then kube API server will further process this command and it will take this command information to the etcd. We will see once understanding these components, we will take a scenario, and in that scenario, what is happening inside the Kubernetes cluster, we will see with that scenario. Okay. Then what is etcd? This is a distributed key value store which acts as the single source of truth about your cluster. How many pods are running, how many containers are running inside the Kubernetes, how many services are running, all those information will be stored in a distributed key value store known as etcd. This is etcd. etcd will be there in the master only, it won't be there in the nodes. Then another component is Kube Controller Manager. This Kube Controller Manager will consist of multiple controllers. One is replication controller, another is node controller. What happens is that the controllers in Kubernetes are responsible for controlling the state of the cluster. In Kubernetes YAML file, what we do is we will define that we should have Nginx service running, and this service has to run in 5 instances. Okay, that is our desire. That is our desired state. So we want 5 instances of the particular Nginx application we want to run. What happens if the 2 containers are crashed? Only 3 containers will be running out of 5. If 2 are crashed, only 3 containers will be running. But our desired state is to run 5 instances. In that case, this controller manager will create 2 instances. which are fail. Okay, let's suppose that we want to have 5 instances of a service. For some reason, due to resource overutilization or some networking reason or the lack of resources on the particular nodes or in the particular Kubernetes cluster, these containers, these 2 instances may be failed. But in Kubernetes YAML file, we stated that we should have 5 instances running, but here only 3 are running because 2 are failed. This controller manager will create 2 instances in this failed instances place, and it will ensure that always 5 instances are running. This is the job of kube controller manager. Then kube scheduler, as the name indicates, it will schedule the pods on a certain node based on the resource availability on the particular node. Through a scenario, I will explain how these things are interacting, how they are communicating. Okay, I will tell you what pod is. Then kube scheduler, assigning tasks to a certain node considering its available resources and the requirements of the task is known as the scheduling. It will just schedule where the particular pod has to be created. Okay, so cloud controller manager, it is responsible to interact with the cloud in order to make this cloud-based Kubernetes cluster working. That is what. If you are running the Minikube, this cloud controller manager will not be there because Minikube will be running locally, not on a cloud. Okay, these are the control plane or the master. What are the components? Kube API server, its prime responsibilities, it will act as a receptionist. Whatever the commands that we are running, use the kubectl, this request will go to the Kube API server. We will see what after the request going to the Kube API server after explaining all these components. Okay. etcd is a just key value store. The cluster information will be stored inside the etcd distributed cluster. It is also a small kind of cluster. Let's say it's a database kind of thing. Scheduler will tell where the particular pod which was requested by the client has to be created, whether it has to be created on the node 1 or whether it has to be created on the node 2 or any other node. That is the job of the scheduler, to schedule a pod on a particular node. What the controller manager does, controller manager will control. For example, if you want 5 instances to be running, for any reason the 2 or any number of instances are goes down, then controller manager will create his responsibility to create the failed instances. That is the job of the control manager. If we are using the cloud-based Kubernetes, there we will be having the cloud controller manager as well. So in this controller manager, one will be node controller, another will be the replication controller. Replication controller responsibility is to create the desired number of pods or to ensure that desired number of pods are always up and running. That is the responsibility of the replication control. What is the responsibility of the node controller? Node controller responsibility is to ensure that desired number of nodes, we may want 5 nodes to be running. In our case, these are 2 nodes. If for any reason one node fail, then it is the responsibility of the node controller to spin up the another node in an automated fashion. That is the responsibility of the whole controller manager. Okay, this is the Kubernetes architecture. Now let's understand the various components in the nodes. Whatever the node that you take, these three components will be there. One is kubelet. Kubelet is the main agent on the node. It is the agent of the master. Kubelet will act as the master on the node. So whatever the master assigns a task to the node, that request will go to the kubelet. Kubelet will take the responsibility of the creating containers, and it will consult the container runtime to have a container running to create the container. That container kubelet will put inside a pod, and that pod will be containing a container or multiple container. In 99.9% of the cases, we will be having the single container pods only. I will explain what is pod, what is container also. Okay. Container runtime. In our case, it's a Docker. Its prime responsibility is to create the containers which are requested by the kubelet. Kubeproxy's responsibility is networking, to create the networking rules for the containers. These are the responsibility of these various components in the node 1. Let's go to the document and see in more elaborate way. Compared to the control plane, nodes have a very small number of components. These components are as follows. One is kubelet. This service acts as the gateway between the control plane, should be control plane, and each of the nodes in a cluster. As I said, every instruction from the control plane towards the nodes passes through this kubelet only. It also interacts with the etcd store to keep the state information updated. How it does, we will experience. We will see. What happens is that whenever we want a service to be created with 4 pods or 5 pods, the request will go to the Kube API server. Kube API server will pass this information to the etcd. It will consult the etcd. I am getting some requests to create the 5 replicas of the Nginx. So what is the status? etcd will tell whether the same things are already running in the cluster or not. If it is running, then this information will be again passed to the Kube API server. This Kube API server, the etcd states that no, Nginx containers are not running as of now, so we have to create the Nginx container and we have to create the 5 instance of the Nginx application. So this information will be passed to the Kube API server. Kube API server now goes to the scheduler and states that the user is asking for Nginx application with 5 instances. Then scheduler will check whether any Nginx servers are running. If it is not running, the scheduler will schedule where those particular 5 instances has to be deployed. The scheduler will decide that two instances of the application has to be deployed here, and 3 instances of the application has to be deployed here. How scheduler will take the decision of where these instances or the pods has to be created? Scheduler will have algorithm inside it. For example, if there is no sufficient resources like memory and CPU are not available on the node 1, then it will schedule more instances on the node 2. So based on the resource availability, the number of instances running on the particular node, then scheduler will decide where the particular pods have to be created in the cluster. That is the job of the scheduler, to just tell where the particular instance has to be created. That is the job of the scheduler. Now, this scheduler will tell that these three has to be created here. These two instances have to be created in the node 1. This information won't be going to the node directly from the scheduler. Instead, the scheduler will pass this information to the Kube API server. Now, the Kube API server will consult the kubelet on the nodes. It says that the scheduler is telling that in this node, 2 instances of the Nginx application has to be created. Okay. Okay. And these 3 instances has to be created here. Kube API server tells to the kubelet of this node and kubelet of this node. In this case, kubelet will get the request from the Kube API server. Now kubelet has to create 2 instances. What kubelet has to do? Kubelet responsibilities to ensure that 2 instances of the particular application is running. In this case, these 2 instances means 2 pods has to be created, right? Pod 1, pod 2, here 3 pods. So kubelet will request the container runtime, that is Docker, to create 2 containers. Okay, this is container 1, this is container 2. C1, this is C2. After Docker creating these 2 containers, kubelet will take these containers and encapsulate these containers inside some abstract layer called as the pod. Okay, it will take a box kind of thing, and inside that box, kubelet will put these containers. These are called as the pods. Pod. Pod is nothing but an abstraction over the container. Okay, to get some uniformity, then kubelet will create the pod. Inside the pod, container will be running. Usually, a pod can contain one or multiple containers, but in 99% of the cases, we will be seeing the single containers pod only in the real time. Rest of the 1%, I will also tell. We will also see how to run the multiple containers inside a pod. Okay. And kubelet will create the pod in the particular node, and this information will be passed to the Kube API server. Kubelet will tell that, and this information will be passed to the etcd. Kubelet will directly report to the etcd saying that I have created the 2 pods, and this information will be taken by the Kube API server. Kube API server will reply to the client. What happens to the request? It will tell if the containers are already created. It will tell the created and running state. If they are being created, then container creating state will be shown there. If it is in pending state, it will tell that the request is in pending state, and we can describe why the request is in pending state. That is how the things will be happening in the Kubernetes cluster. Then, what is the job of kubeproxy? The kubeproxy's job is to create the networking among the containers that are created inside the node, and to route the traffic which is coming from the outside to the containers based on the request and based on the traffic. So kubeproxy's job is networking inside the node. This is what the Kubernetes architecture is and all its components. Here in this case also, containers will be created by the Docker. This is C1, this is C2, this is C3. And these containers will be running inside this. So total 5 instances were running. If some reason all these pods are crashed, the controller manager will create the 5 pods in these 5 pods places. That is what it does. So this is the job of various components in the Kubernetes cluster. Okay. Now, now, so pods are the smallest deployable units of computing that you can create and manage in Kubernetes. Okay. In Docker, what is the smallest deployment unit? It was container in the Docker. But in Kubernetes, all these containers will be wrapped in a abstract layer called as the pod. Okay, that is. A pod usually encapsulates one or more containers that are closely related, sharing a life cycle and consumer resources. For example, in the logging agents, we will be having the multiple containers. I will show you where it will happen. So, you see, we have the Kubernetes cluster. Inside the Kubernetes cluster, we have the node. Inside the node, what we have? We have the pod. Inside the pod, we have the container running. This is how the container will be created inside the Kubernetes cluster. Okay. Generally, we should not create the pod directly. Instead, we will create the pods using the deployments in the replica sets. Whenever you are going to practical, then only you will understand this statement. We have seen what pod is. Then what is service? We are creating a Nginx image, right? An Nginx image we are creating, Nginx service we are creating. So these containers are running, these Nginx containers are running inside the Kubernetes cluster and they are running inside the node. Then how to access this Nginx application? We should have the routing roles. How to expose these Nginx containers to the outer world means how to access these Nginx application. For that, a service will be there. A service in Kubernetes is an abstract way to expose an application running on a set of pods as a network service. Okay. As a load balancer, we can expose this service. As a node port, we can expose this service. We expose using the cluster IP, we cannot access through the outer world. This we will experience in the practical. Okay. So we have the Nginx application running in 5 replicas. In order to access this Nginx application, a service has to be created. Service is nothing but a Kubernetes object that is used to access this application from the outer world. Okay, that is what it is. Here also, in these nodes also, these containers will be running inside the pods only. So with this, how we are able to get the high availability, even if the one pod is crashed, automatically a new pod will be created in its place. Even if the one node goes bankrupt or one node is failed, automatically a new node will be spinned up and whatever the pods that are already running this failed node earlier, those will be scheduled automatically on the new nodes. This is how even if the one container is deleted, then we will be having another container. Still, we have the high availability. When the entire node is deleted, even if the entire two nodes are deleted, also automatically two nodes will be created in these places. This is how the Kubernetes will orchestrate the containers. Orchestrate means it automatically deploys the application and manages them and networks them. That is what the orchestration meaning. There are two ways to create the services in the Kubernetes. There are two ways to create the services in the Kubernetes. One is let's take this screenshot of this. there are two ways. Even if you take any infrastructure as a tool concept or whatever, so in DevOps, there are two ways of creating the services or whatever. One is imperative way, imperative approach. Another one is declarative approach. These are very important terms in the DevOps. In imperative approach, let's say you have booked a cab to go from LB Nagar to some Madhapur or the Miapur. You will book the cab in Uber. What you will do? You won't guide him. You won't guide saying that first initially, if it is not Uber, generally what we do is we will get onto auto. We will tell that first take the first left, then take the second left. In this way, we will tell each and every time after going some distance, we will tell that please take the first right or something that we will direct each and every time to go to a particular destination. This is the destination. This is the starting point. So instead of this is how we are telling this kind of approach is called as the imperative approach. In the Kubernetes, whenever we want to create a service, we will run the commands manually. First, we will create the service. If we want to fire replicas, we will scale the particular service using the scale command. In order to expose this, we will run another command manually. So this approach is called as the imperative deployment approach. In this approach, we have to execute every command one after the another manually. Okay. In declarative approach, what happens is that in Uber, what we will just tell to the Uber auto driver that I have to go to this LB Nagar to the Madhapur or the Miapur. Just you will tell, will directly take you there without asking anything, because we have told all the instructions were there in the Google Map or whatever is there. So that is a script is there, a file is there. Already we have told that is called as the declarative approach. So in Kubernetes, declarative way means in order to create a service, what we do, we will define all the steps in the Kubernetes manifest file that is written in the YAML language. YAML language consists of what? Key value pairs. So in this, what happens is that we will declare the steps inside a file that is called as the declarative approach. So let's create some services using the imperative deployment approach. I want to create Nginx application. I want to create Hello Cube application which will use the Nginx Docker image. Let's name this as Hello Nginx. Okay. What we will do? For that, what we should have? We should have a Kubernetes cluster already and kubectl command line tool installed in this. Somebody is raising their hands. Yeah, could you please tell what's your doubt? Somebody is raising their hand. Sandeep. Yes, Sandeep, could you please talk?
So screen is not sharing, sir. It's empty.
Screen is not sharing.
Yeah, sir.
Gayatri, you also raised your hand. What's the problem? Screen is not being shared. Is this problem for everyone or only for Sandeep? Could you please
No, sir.
ping
It's
in the chat?
totally it's blocked.
No, I am asking others. Yeah, Akshay, can you please tell? Screen is visible or not?
Yes, sir, visible.
Yeah, it's visible. Sandeep, it's problem from your side.
So it's not showing any screen, sir. Here.
Yes, visible. Everybody is saying that it's visible. Please rejoin. Please rejoin.
Okay, sir. Okay, okay. Thank you.
Okay. So in imperative deployment approach, we will run the command for each and every thing that we want. First, we will create the application. And if we want to have 5 replicas of the application, we will use the kubectl scale application command. That way we will be running each and every time a command will be running to get the particular desired state. In declarative approach, we will write all these steps into a Kubernetes YAML file. Okay, that is. So let's connect to the Minikube. So Minikube is a single node cluster which we can install inside our local machine, and we can use this Minikube to practice. And if you don't want to Minikube, if you want to use cloud-based services Kubernetes clusters, then in AWS, we have Elastic Kubernetes service. Let me quickly show you. Log into AWS Management Console. For that, you should have already AWS account. What I recommend is instead of using the Minikube, please use some real-time clusters like EKS or AKS, or design your own Kubernetes cluster using the KubeADM. We will design our own Kubernetes cluster in our course. So in search box, search for Elastic Kubernetes service, or just type EKS. See, where it will show you Elastic Kubernetes service. There, go to clusters, create cluster, cluster name. You have to write here the Kubernetes versions. There are different versions of the Kubernetes. You have to create the some cluster service roles in order to give access to the AWS to the particular cluster. We have to create the IAM role here, tags, and the next we have to create the configure and all those things. This way you will be create the Kubernetes cluster in the AWS. I will also show you that in the course. Okay. After that, how you have to interact with the Kubernetes cluster. I have told that there are 2 ways to interact with the Kubernetes cluster. One is through graphical user interface. In most of the cases, in real-time scenario, we won't use the graphical user interface. Instead, we will use the kubectl command line. Generally, it is called as the kubectl. This kubectl you can install in the Windows as well, and you have to give the environment variable for that, so that you can access the through command line. See, kubectl version. If you check this version, see, it will be showing. So in short, you can see this as well. Okay. When the version is there, you have already. This is the version. So if you check whether it's running or not, you just kubectl, then it will show all the commands associated with this kubectl command line interface. Okay. This is how. So I want to use the Minikube as of I want to show you cloud-based cluster. I will show you how to use them, how to design them in the during the course. Let's say in order to check the status of the Minikube, as I said, Minikube is a single node Kubernetes cluster which can be installed in our local machine. Minikube status. We are fetching the Minikube status. If it is running, it will show the running state. See, what is the status of the Minikube? It's running. Kubelet is running, API server is running, kube configure is also configured. Okay, this is. Now, how to see the number of nodes? As I said, Kubernetes cluster will be having the master and the nodes, right? So we'll see In order to get the number of nodes, we use the kubectl get nodes command. See how many nodes are there in our Kubernetes cluster? We have only one node, and as I said, minikube node will be acting as the control plane, that is master as well as the node. In this minikube node will take itself loads as well. But in general, in our Kubernetes clusters and real-time Kubernetes cluster or the cloud-based Kubernetes cluster, we will be having the master and the number of nodes that we have created, and we can also enable the auto scaling. If the traffic is going on increasing, then automatically new nodes will be created. In production, we will be having the tens of nodes, hundreds of nodes as well. Okay, that is how. Then how to see the pods? As I said, pod is a smallest deployment object or the entity that can be deployed in the Kubernetes cluster. Let's check Kubernetes get pods. Earlier, in order to list out the nodes, we have used the get pods. Let's see. These are the pods that are running. And in Kubernetes, we have the concept of namespaces to categorize various applications, to compartmentalize various applications within the Kubernetes cluster. You will also learn the namespace concept extensively. Okay. So if you are not mentioning any namespace, by default, you will get the pods or the objects within the default namespace. Okay. If you want to get the pods in all the namespaces, kubectl get pods use capital A. See, these are all the pods that are running in the particular minikube cluster and in all the namespaces. In this way, we will see. Now let's go to the integrative approach. Let's execute few commands and experience the Kubernetes. Now, I want to run Hello Nginx application. I want to name that application as the Hello Nginx, and I want to use the Nginx image. Where this image will come from? It will come from the Docker public registry. If you are not mentioning any registry, then this will be coming from the hub.docker.com. Docker.com. This is the public registry. This is container registry where all the container Docker images will be stored. This is one. So I want to create Hello Nginx application by using Nginx Docker image, and I want to expose the port 80. Let's experience. Run this command here. See what is happening. You have to read this. Pod with the name Hello Nginx is created. This is the status. When we are running this command, what happens inside the Kubernetes? Inside the Kubernetes, this kubectl request has went to API server. It has gone to the API server. This API server will consult the etcd cluster, will tell the status. What is the status? The client has requested to create Nginx application using the Nginx image, and this etcd database will be having the data about this Kubernetes cluster. It will check with this. etcd will tell that no, as of now we don't have any application running with the particular Hello Nginx name. It will check, but it will give this information to the Kube API server. After this information is being given to the API server, it will consult the scheduler with that information. and scheduler will tell that this particular Hello Nginx application has to be created in the node 1. It will tell this information will be told to the API server. This API server with this scheduler information will consult the kubelet. Kubelet now got the information that in this particular node 1, a pod has to be created with name hello nginx, and the container has to be come from the nginx image. So who will create the container? The container runtime, that is Docker, will create the container. So this kubelet will ask the Docker to create nginx container. So Docker will create the nginx container, and this container will be taken by the kubelet, and it will put that container inside the pod. What it does, it will put the container inside the pod. It will encapsulate the nginx container inside the pod. This is the container, this is the container, and this is the pod. Okay, that is how the kubelet will create the pod in the node. After creating that pod, this information will be given to the master, and this API server will pass this information to the kubectl. What information it passed? It passed that pod hello nginx is created. This is what we got the output from the kube API server. Now, how to check whether this hello nginx pod is created or not? For that, kubectl get pods command. See, hello nginx is created. How many replicas? Only one replicas, because we wanted to create only of the particular pod is running. What is the restart? The container is not restarted. What happens is that sometimes the container will be stopped due to resource unavailability and whatsoever the reasons, or some breaks in the container, the process. So in that case, the container may restart automatically in order to interrupt the service. So the container is not restarted as of now. It is successfully running. If some problem comes to the container, it will be restarting automatically. Okay. What is the age of the pod? This pod was created 3 minutes 22 seconds ago. That is the status of the particular pod we have created hello nginx. Okay. Now let's describe it. In order to describe this pod, we have to use kubectl describe pod hello nginx. Sorry. Hello nginx. If you see the description, this is the name of the pod. This is the namespace on which we have created. This is the priority number. This is the node. This is the start time. This is the labels, annotations. All these things you will learn one by one in the course. This is the IP address of the pod. I said that the responsibility of the kube proxy is networking. This IP will be created to this particular pod by the kube proxy. Okay. The containers, what are the containers that are running? This is the container ID, that is the image ID, the ports, the status is running, the started, whether the container is ready or not. This is what you have to read all those things. So this is the condition of the particular pod. These are the volumes that will be attached to this. We will also see the volumes, and we don't put any node selector. So that's it's null. The tolerations. We will also see the times and the tolerations in the during the course. And what does the scheduler has done? Scheduler has scheduled this pod to create it on the particular node. Okay, so it is successful. Kubelet scheduler has successfully assigned some node to this pod. To whom it is assigned? To the minikube node it has assigned. After this, what is kubelet is doing? Kubelet from kubelet, the information we got is that kubelet is telling is that image is pulling from the this particular nginx image is being pulled from the Docker container registry. The kubelet is now giving the information that successfully pulled image, the container is created, the container is started. Okay, this is what the description of the particular pod that we have created using the kubectl run command. Okay, that is, let's clear the screen. Like that, multiple pod, allow nginx is one pod, allow cube, this is already created. So this is nginx. How to delete this particular pod? Let's delete the earlier pod, kubectl delete. The command is kubectl delete pod. What pod I want to delete? I want to delete the Tomcat pod. See, pod Tomcat deleted. So once this is deleted, this information will also be updated in the etcd cluster. Etcd will be having the updated information from time to time. This is now if you run the kubectl get command, see this Tomcat pod is not there. Let's delete this as well. Kubectl delete pod hello cube. Sure. Okay, this is how. There are number of ways to create the application, to create the services in the Kubernetes using the kubectl. One is imperative way through commands. One is the declarative way by creating the Kubernetes manifest file that are YAML files. And as I said, Kubernetes will be having many objects. One is pod is an object, deployment is an object, replica set will be another object, secrets will be having another object. They are all the different objects in the Kubernetes. Here we have read a statement. Generally, if you create the class of pods with the pod, then we cannot manage it. What does it mean is we are having only one instance. It won't automatically create the 5 replicas if you want. We have to manually replicate this particular service. But even if you want to update, that update option is not possible with the pods. We can create the pods using the deployment. So deployment, if we create using the pods, we can mention the number of replicas. We can mention the rolling updates and the rollbacks within the deployment. We will experience, you will understand only if you experience that through the practically. Okay. That is one thing. 2 participants have raised their voice, hands. Who are they? Yeah, can you please speak out? Gayatri. Okay, nobody is having any question. Let me go. We have created the nginx application and the pod is running. But how to access this application by the customers, by the client, by the users? How to do that? For that, as I said, we have to create a service for this particular pod. Then only that application will be accessed from the outside the Kubernetes cluster. See, now this application is running inside where? Inside the cluster. Inside the cluster also there it is running inside the node. Inside the node it's running inside the pod. Inside the pod, inside the container it is running. So how to access this application? In order to access the application, we have to create a service for the application. Creating a service means we have to expose the service. We have to expose this pod to the outer world. Using what? Using the load balancer type of the service. We have load balancer type, we have the node port. This section will be Srujan, this will be provided in the Telegram. This session will be uploaded to the Telegram. Okay. My desire is how to access this application from the web. For that, we have to expose this particular pod. How to do that? How to do that? kubectl kubectl expose. What do you want to expose? I want to expose this hello nginx pod. With what type of service we want to expose? With the type load balancer, I want to expose this pod to the outer world, and we want to expose the port 80 of the particular container. See, when you run this command, please hold on. Somebody is raising their hand. I will attend to you. Wait for a moment. This application is accessed. So how do you know that? kubectl get service. This is how to list out the services. See, this hello nginx service is created 49 seconds back, and the port to which we have exposed it is 280. So this is the cluster IP, which is for internal communication of the pods within the Kubernetes cluster, and we have exposed this to the load balancer. If this is the cloud-based Kubernetes cluster, then we will get the external IP. External IP will be assigned by the particular cloud provider. With that external IP, we can access this through the web browser. But if you are using the mini queue, there is another way to access this. How to do that? So this run service has to be explored through the tunnel. We will see how to access this. Minikube service, Minikube service. What service I want to access? It will be forward to the tunnel. I will show you that. See what is happening. I want to access this service. What happens is that this hello nginx service will run as a process. Okay. First, let me read this. Creating a tunnel to the content cluster, because we are not having any cloud-based service here. The command exposes service directly to any program running on the host machine. It will create a tunnel for this service. See, whenever we are accessing this, a tunnel will be created. Okay, opening service default in the default browser. Because you are using a Docker driver on Windows, the terminal needs to be open to run it. Okay, this is how a tunnel will be created for the particular service. In the cloud, you will get the public IP address, external IP address. With that external IP, you will be accessing this application over the web. Now, here see, this application is accessible to the web. What are the different ways to expose the services other than the load balancer? Krishna is asking. We can expose this to the node port as well. With that, through the node IP address, we can be able to access this service. When we are going through the course, you will learn each and every type of this service extensively, intensively, and you will also experience that practically. Okay. See, this nginx server is now accessible. Where this nginx is running, you see, we have the Kubernetes service, Kubernetes cluster. Inside the Kubernetes servers, we have a node. Inside the node, we have the pod. Inside the node, we have the pod. Inside the pod, we have the container. Inside the container, we have the nginx application running. This is what? This is cluster. This is what? Node. This is what? This is what? Pod. This is container. Inside the container, this Nginx application is running. We are successfully able to hit this service. Hit this Nginx service from the outer void. This is how it happened. Now, let's stop this. Let's refresh this again. So if you are using the cloud-based thing, automatically, if you are using the load balancing kind of a service, automatically an external IP will be attached to this particular service with that external IP and the port. Then we can access this application. Let's stop this. Stopping the tunnel for service my Nginx. Okay, how to delete it? kubectl get service. In short, you can also use kubectl get svc also. I want to delete this service, or before that, let's experience few more commands before deleting that. We go to my document. See what is happening when we are accessing this to the web. We'll go to the load balancer service. That load balancer service will route the traffic to the particular container. Okay. As I said, we can create the pods using the run command. By default, pod will be created. We can create the deployment for the particular my Nginx pod. What is the advantage of that? If we are creating the deployment for the particular pod, particular service, then we will be having the many advantages. We can scale out. In this case, we cannot create the multiple replicas. We can only have the single pod created for the particular service. But if we use the deployment, then we can have the multiple replicas of the particular service. That is the whole objective of the Kubernetes service. In order to have the high availability, we should have the multiple replicas of the particular Nginx application. Then only it will be fruitful. Even if the one container is crashed or one pod is crashed, the request will be served by the other pods. That is the whole point of having the Kubernetes service. So we generally don't create the containers using the pod. Instead, we will use the deployment. So before that, let me delete this. Let's delete this kubectl delete. If you want to delete pod, use the delete pod. If you want to delete the service, use the delete service. What service you want to delete? Hello Nginx. See, this is delete. You go here. See, hello Nginx is not there here. So let's delete this service server. Delete svc. Let me delete this as these were earlier created. Let me go to pods and delete the pods as well. kubectl delete pod. See, as I said, Kubernetes will allow us to create the pods whenever the pods are deleted, right? But here the pods are not being created because we are not using we are not using the deployment. If you use the deployment, you will see that even if you try to delete the pods, in their place automatically new pods will be created. Let's delete this pod as of now. See, pod is deleted. Okay. I think this is the deployment is running. So this is earlier one. Don't worry about this. I'm clearing that as well. kubectl delete deployment my Nginx. I want to delete this. So let me check what are the pods that are running. The default namespace. As I said, if you are not mentioning any namespace, by default, the components in the default namespaces will be shown. Okay. Let me attend to your question. 4 people are raising their hands. Venkat, yeah, Venkat, please speak.
Yes, sir. This Kubernetes completely clustering only like a load balancing, like maintaining like a multiple Dockers like that. It is maintained actually.
Ah, this Kubernetes purpose is to orchestrate the containers.
Mm.
How we will do is that, for
Container,
example,
Docker containers.
yeah,
Mm.
Docker containers. You can also use this Kubernetes for Rocket containers also. Okay, but in
Okay.
most of the
Rocket
cases we use the
containers.
Docker containers only. Yes,
Mm.
yes. There are other containers tools as well, right?
Okay.
Like the Rocket. So you can use this
Mm.
Kubernetes to
And
orchestrate Rocket-based containers as well.
this also running in the cloud system, sir, or otherwise only Docker container, Docker images only running in the cloud platform actually. Kubernetes also can be run in the cloud environment like AWS cloud, OpenShift, right?
Yes, we can create our own Kubernetes cluster in cloud, or we can
Mm.
use their
Mm.
own managed service.
Mm.
If you don't want to create your Kubernetes cluster using the kubeadm tool or such
Mm.
kind of tools, you can use the managed service which is being provided by the AWS, but it will cost some money. In order to use that Kubernetes
Okay.
service, ultimately, even if you are designing the
Mm.
Kubernetes cluster using the kubeadm tool also, you will be having some EC2 machines using in the AWS. So
Mm.
that way also you will be costed for
Mm.
that. But even if you use
Okay.
the
Mm.
Kubernetes AWS service also, there also it will be costing, but because you are using the managed Kubernetes service, definitely some more cost will be additionally you have to pay.
Okay,
Okay,
sir.
in
Okay.
Azure we will be having the
Mm.
Azure Kubernetes service.
Mm. Okay, 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 sir. Yeah.
Okay then,
Okay, sir. Yeah.
right. Next, Srinivas.
Sir,
Srinivas, you raised your voice. Yeah.
hello.
Yeah, Srinivas, I'm able to hear you.
Sir, what is the purpose of that proxy, sir? Who proxy?
Kube proxy purpose is, as I said, because in a particular node, we will be having the multiple containers, right?
Yes, sir.
So we are hitting this service here. We are hitting the service like this.
Yes, sir.
So to which container the request has to go?
Ah,
So that routing rules, that networking rules will be created by the kube proxy.
ఓకే ఫైన్. అదే
As simple
మీరు
as that.
ఫాస్ట్ గా చెప్పేసరికి అదే కొంచెం క్లారిటీ మిస్ అయింది. థ్యాంక్ యూ సార్.
Yeah. Okay. No problem. Okay. Some people is also Pavan. Pavan, could you please ask your doubt?
Yes. In Docker, we have Compose. Apart from that, we have Swarm for the orchestration. So suppose we want to deploy application by using the Apache. So instead of NGX, so there is any possibility or that we need to do like deploy in the NGX server only.
No, we can use the Tomcat also. Can use the Tomcat, whatever the image, whatever the things that you are able to do with the Docker that can do here also, but you will be having an automated fashion, high availability, multiple replicas, multiple nodes. We will be deploying the containers in the distributed environment. Okay, you can use the Tomcat also, but for example, I have shown you the this one, this Nginx. Okay.
Okay. And second question is that, sir, suppose we have the full stack like application. My UI is like placed in the zone one, and my like backend and other microservices is deployed in the zone two. So which is the better way? It will be like Docker or Kubernetes for the orchestration purpose.
Finally, if your project is being the services, the microservices are being deployed in the Kubernetes means automatically you will deploy in the Kubernetes only. In the background, Docker will be there for containerizing this. As I said, right?
Okay, got it.
In
Yeah.
the nodes, Docker is the responsible for creating the containers. We are using the Docker for creating the containers. These containers will be managed by the Kubernetes.
Like a
Okay,
load balancing, sir.
got it.
Load
Yes,
balancing,
yes,
it means.
yeah, yes,
Thanks,
that's
thank
it.
you very much. Yeah.
Okay, okay, sir.
Okay, I'm noting
And but
Venkat.
how the application
Yeah, Venkat asked.
Yes, sir. That means application is interacting with the Kubernetes, the URL, then this Kubernetes taking like any one of the Docker image, like it is executing like that happening, sir, internally. When
Yes,
you
yes.
access the application, I mean to say.
Yes. So the request will go to any container. Okay.
Mhm.
If you are, if a single, if
Any
apart
container.
from, yeah, if the 100 requests
Mm,
are coming at a time, if you are hitting the service, I'm hitting the
mm,
service, it doesn't mean that
mm,
this request will go to only this particular containers. If you have 5 replicas, your request will go to
mm,
one container, my request will go to another containers. That way it will
mm.
happen. Okay. So the
Okay,
request will
sir.
go to the multiple replicas and the load will be shared across the multiple containers and the multiple nodes. First, it
Okay,
has
okay,
to
sir.
go to the node, and from node, it has to go to the pods.
Po- Pods. Pods means contains like a multiple images, sir. Pods contains multiple.
Pods can contain multiple containers, but usually we will
Mm,
be having only single container pods only. Pod is nothing but
mm.
an abstraction over the container. Okay, it's a
Okay, okay,
box
sir.
kind of thing. Okay,
Mm-hmm. Okay,
that's
sir.
it.
Yeah, yeah,
Okay,
got it.
Venkat.
Got it. Got it. Thank you. Yeah.
Okay. So whoever don't have does please down their hands and Gayatri raised her hand. Gayatri, can you speak now? Maybe by mistake she has raised her. Okay, Gayatri. Then you have Sultan. Yeah, Sultan. Sultan, you have raised your hand, right? Okay, no problem. Let's proceed with the
Yeah,
discussion.
one more doubt, sir. Actually, these node pod are the part of the Kubernetes only, sir. Node
Yeah,
pod,
these are
these are
all
the
the
part
part
of
of
the
the Kubernetes
Kubernetes.
cluster only. These are all the part of the Kubernetes cluster
But
only.
but container is nothing but a Docker, na, sir. Docker, na. Container is nothing but a Docker.
The statement is wrong. Your intents may be good, but the
Mm,
statement is containers. These containers are
mm.
created by the Docker only. Okay,
Okay, okay.
because if
Mm,
you go to the
mm,
architecture, if you go to the
mm,
architecture, you see this kubelet will
mm,
request the Docker to create the container. Okay, Docker will be
mm,
there in the Kubernetes.
mm,
You have to understand that
mm.
Kubernetes is not a
Okay, sir. Yeah, yeah.
replacement or the substitute for the Docker. Kubernetes uses the
Okay.
Docker to containerize the application, and in addition,
Mm.
Kubernetes will orchestrate the containers which are being created by the Docker.
Okay, sir. Yeah, yeah. Got it. Got it, sir.
Okay.
Yeah. Yeah. Thank you, sir.
Yeah, Chandan, you have raised your hand.
Yes, sir.
Yeah.
So, sir, how Kubernetes know that if any pod is in crash loop backup or crash or hung?
Yeah. When the pod is failed, that's what, as I said, controller manager will be there, right? For example, a pod is failed when the pod is deleted or whatever. So he is a controller manager, especially the replication controller manager will ensure that the desired number of pods is always running. I will replicate. I will simulate that scenario here. We will create the Nginx 5 replicas of the Nginx, and we will see. We will try to delete the pod. What will happen automatically? A new pod will be created. So it will be having some algorithms inside. With that, it will etcd cluster the data will contain. Whenever the pod is deleted, the etcd will be updated with that status. The API server, this control manager will be keep on tracking the status of the pods. With that, it will create the new pods in their places. Okay. When
And
we are
sir,
going to the practical more deeply, you will understand what will be happening inside. We will be generating the logs for the particular pods, and in those descriptions and the logs, we will understand. Okay.
and sometimes in project the pod restart count more than 100 automatically. So, what is the cause for that automatically restarts?
Yeah, automatically restart means we are not having any downtime. Whenever the Kubernetes comes to understand that particular container is not running, it will. It's the job of the Kubernetes to start it. because we will put the policy, right, when to restart the container. Always whenever the container is stopped, then automatically it will restart the pod. Okay, we will experience that. Okay, it is very premature to do that. We will experience this. Okay, let me proceed with the discussion. Thank you. Yeah, so what we are trying to do now, as I said, generally in the real time, we will create the pods using the deployment Kubernetes object. Let me show you how the Kubernetes is trying to see. First of all, let me show you there are no pods. There are no pods in the default version. I am going to create a deployment. I will tell you what is deployment, what is the replica set, because this is a free workshop. I just want to show you how this Kubernetes is working. Earlier we have created what pod. Now we are creating the deployment. kubectl create deployment. The deployment name is my nginx. Okay. How to do that? When this deployment is created, inside this deployment, we will create the pods only. But we are creating the pods using the deployment. Okay. See, now the deployment name is my nginx. This deployment has assigned a name to this particular pod using my nginx as the prefix, and it is giving some ID to the particular pod in this fashion. And this particular pod came into the running state. Yes, I will. I'm raising the hand. Okay, Raj Lakshmi, I will attend to your question. The last one. Where is Raj Lakshmi? Raj Lakshmi, I could not see you raise your hands. Yeah, Raj Lakshmi, could you please speak out?
Hello.
Yeah, Lakshmi, I'm able to hear you.
Yeah. Sir, all commands I understand, but you in command prompt you give Kubernetes kubectl hyphen version. After that, before that, what command means what command I will give and it will install, sir, for Kubernetes installation.
To install Minikuba?
Yes, sir.
Okay, I will tell you. I will give that in the document. There will be steps, right? So because this is the demo workshop, then I did not go through how to install Minikube and all those things because that takes time. So in order to install the kubectl and Minikube, that will be there in the documentation. Okay.
Okay.
Okay. After your subscribing to the class, that will be available in the documentation. Thank you. Now, see, this particular deployment has created this deployment, and with this deployment, a pod has been created. As I said, deployment came with the features of creating multiple replicas. How? Let's experience that. So what I want to do, I will expose this using the service, but my intention is not that. I want to have multiple replicas of the particular my nginx application. How to do that? So for that, we have to scale the deployment. I want to scale which deployment? I want to scale this deployment, my nginx deployment. I want to have 5 replicas. Now we are having only 1 replicas. I want to have 5 replicas for this particular deployment. How to do that? Please hold on, guys. So after 10 minutes, I will take up your question. See, what I want to do, I want to scale this deployment to 5 replicas. See, the deployment, my nginx was scale to how many replicas? 5. How to check? kubectl get false. See, 5 replicas are created. 1, 2, 3, 4, 5. Some are already came into running state. Some are they are being created. Okay, let's check now. See, all the 5 replicas are came into running state. Okay, one was already created, And because we want to 5 replicas, 4 were created now. The desired state is 5 now. The 5 containers are running. 5 pods are running. See, then we can see this deployment also. We have created the deployments. For that, the command is kubectl get deployment. See, we have only one deployment. For that deployment, we wanted to create 5 replicas. Out of 5 replicas, 5 are in ready state, 5 are up to date, 5 are available means 5 are running. What I said is that the controller managers which are there in the master will ensure that desired number of the replicas are always up and running. That means if some reason this pod is deleted, what happens? Automatically, immediately, a new pod will be created in its place so that the total number of replicas will be 5. Let's delete one pod. Let's delete this pod. How to delete a pod? kubectl delete pod. The pod name you have to give. See, now immediately go to kubectl get pods. See what is happening? What is happening? See here. Because after deleting this pod, we will be having the only 4 pods. But our desire is to have the 5 pods, right? So in this case, automatically a new pod is being created immediately. So that Kubernetes will ensure that the desired number of pods are always running. If you don't want to have 5 pods, you want only 3 pods, then you can't delete it because Kubernetes don't know that whether you are wantedly deleting it or the pod is deleted because of some reason, right? So that's why a new pod is being created. That is the thing. But some reason you may be telling that during nights because there won't be any much traffic, so only 3 containers are sufficient to handle the request. In that case, what you do, you will scale down the replicas. How to scale down? The same command instead of mentioning 5, instead of mentioning 5, we will mention 3. Now go to cubes. Now in this case it is scaled down. The replicas are scaled. See, only 3 are running. Out of these 3, you wanted to have 3 replicas running. What happens if you delete 1 replicas? Delete pod. Which pod? Let's delete this pod. This pod. See, deleted. kubectl get pods. Automatically, immediately a new pod will be created in its place, right? This is how the controller manager will work. Will ensure that the desired number of pods are always up and running. So, how to expose this deployment? You can expose this deployment like we did for the pod. See? So this is already exposed, right? Have already kubectl get SVC. So because this is not the cloud-based Kubernetes, we did not get any external IP assigned to it. So here we don't have any. So how to access this? Minikube service my nginx. What will happen if 100 people are hitting this? If you have the external IP, we will also be able to hit this, but we don't have external IP because we are using the local. See? So whenever I am hitting this service, it will go to one or the other pod. Okay. So we have 3 pods running. So it may go to traffic will go to 3 pods. If you are also hitting, my traffic will go to this and go to this. Likewise, the traffic will be distributed across the pods. That is how it will be working. See, I have stopped the tunnel. Get pods. How to do that? So here we are using what kind of approach? Imperative deployment approach. We are saying that we are creating the deployment. After that, we are scaling the deployment, and we are creating that. Whenever we don't want to have this, we are scaling down. It should automatically happen, right? We should have declared inside a file, and if we apply that file using the kubectl apply command, automatically the parts has to be created, the port mapping has to be done, the services has to be created. Automatically, the parts has to be scaled out, scaled in based on the load. That will be seen in the declarative approach. That is, we will be having the YAML file. So for time being, let's delete this deployments, kubectl get deployment. If you want to delete this pods, you have to delete the deployment. You cannot delete the pods. What happens if you try to delete the pods? Automatically, new pods will be created by these deployments in their place. kubectl delete deployment. Which deployment I want to delete? This deployment. You can create the multiple deployments. kubectl get pods. See, the deployment will delete all the pods. Let's delete the service as well. kubectl delete service or delete SVC. Can use my nginx. This is how kubectl get SVC. Now let's do the same thing with the declaratively. How to do that? For that, we will be having the API version kind metadata spec. I will explain this during the regular classes, but a last and final thing, let me further experience this. We have to create the pod definition.yaml. How to do that? Let's do this. Let's create pod definition. Let's delete these things. Let me delete these files. Let me delete pod.yaml or pod definition. Definition.yaml. You can give YAML or YML and copy this content. You will understand API version kind everything during the classes. Last and final. See, this is what image we are using here. We are telling that the name of the pod should be my app pod. These are the labels to be identified with the service and all those things. You will learn it. So inside the containers, we are specifications we are mentioning. Inside the specifications, we have the containers block. In the containers, I want to name that container as nginx container. What image I want to use? Nginx image. The Kubernetes will, the Docker will pull this image from the Docker hub and it will create the container from this. Okay. So this is kind is pod. We want to create this as a pod, not the deployment. If we want to create this as the deployment, the definition file will be different. We will learn during the course. So how to create the pod from this file? For that, go to the particular directory. We are in the same directory where it is file kubectl apply or create. Initially, you can use the create. The pod is already created. If you want to make changes, then you can use the apply command. Okay. kubectl create -f provide the file pod definition.yaml. See, same here also. When we are using the command line also, the pod was created. Now using this also pod was creating, but we are not mentioning step by step. We are using the deployment. We will mention the replicas as well. The number of replicas that we want. Okay. The service also we can do this. See, kubectl get pods. This is the declarative way of doing. The pod is came into the running state. How to expose this pod? Earlier we have used the expose option. Now you have to create this inside the some service file. You can name whatever the name you can give. Let me give pod svc .yaml. Inside this, create this. See, what type of service you want to create? Load balancer. If you want to have node port, you can create the node port. These are the port that we are exposing to. Now, kubectl, we can use the apply as well. Apply pod, sorry. See, so the particular service was created. Use it well. Where as we see how to access this, let me close earlier Nginx. Let's close this. Close this as well. Now, how to access this? We need to service my app service. The tunnel will be open for this. Automatically, the browser will see we're able to access the Nginx. This is how declaratively we can do. As I said, we cannot have multiple replicas with the pod. You can achieve with the deployment kind. Okay. So for that, we should have the deployment and all those things we will experience during the regular classes. The regular classes will start tomorrow at 7 a.m. Class will be from 7 a.m. to 8:15 a.m. 7 a.m. to 8:15 a.m. So especially for this Kubernetes classes, the fee will be, all those details will be there in the Telegram group. The course duration will be 2 weeks. We will all see the real-time things only. We will all see the practical things only. And have given the, I will give the a well published, well refined document with you. So even if in the real-time project also, you can use this document. Okay, you will see. This is only 48 pages. We will be having other documents as well. Just whatever the commands we will be using in the real time, all the commands will be there here in the definition files. You can, for example, in your Java application, if you have already containerized the Java application, if you want to create the Kubernetes YAML file, you just have to copy this and you can change the parameters with this. That is how this will be very beneficial. Please subscribe the course, friends. That is, if you have any doubts, please ask. I will allocate this 10 minutes for the doubts. Okay. Yeah, somebody is saying, can we run multiple containers into a single pod? Yes, we can run the multiple containers inside the pod, but in industry, in the real time, mostly you will use the single container pods only. Okay. Then somebody is raising their hand. Who is raising their hands? Can you meet people? All of you lower your hands and come afresh. Sir, what is pod? Pod is nothing but a single smallest deployment object in the Kubernetes. Pod is nothing. What is the difference between pod and container? If you understand that, then you will understand. Container will be just kept inside a box kind of thing. That is called as the pod. As simple as that. Don't think beyond that. Okay. Pod is an abstraction, a layer over the Docker containers. And Docker it will be called as the container. In the Kubernetes, that the smallest deployment usable object is called as the pod. What is the difference between pod and the node? Pod and the node, what is the difference? Node is, we have in the Kubernetes, we will have the Kubernetes, a node is nothing but a EC2 instance. You can think of in AWS, it is a EC2 instance. It's a Linux machine. If it is Azure, it's a virtual machine. It's nothing but your computer is a node. We are installing the Minikube, right? Here the Minikube itself is a node. Install in the node, what we are doing, our application is running as a container, as a pod. Lot of difference between the pod and the node. We can have multiple pods in the node. Node is nothing but your Linux machine. Then, okay. You will see the real-time things only in the Kubernetes. Practically, you will do whatever the theory that we have to explain. It's already over. We will get some theory. We will explain what is pod, what is deployment, what is replica set, what is service, what is cluster role binding. All these things we will see. What is config maps, what are secrets. Okay, that is. We'll also see a real time things. All things will be real time only. Somebody asking some questions. What is the purpose and role on the Nginx? Nginx is a server, right? If you have a web application, then we will deploy that into the Nginx. Sir, can we create, run multiple services as a container in a pod? Services as a container. Whatever you are able to do in the Docker container, that can be done in the Kubernetes. For example, in container, what we will do, you will run a Nginx application or a Tomcat application. In that Tomcat server, you will run your Java application, right? So that way we will be doing here as well. Somebody is saying, sir, if I can create multiple replicas in my application, we are using local cache memory. We have used its access across all multiple other instances also. Yeah, if you are using the environment variables in the deployment, those variables will be same for all the pods which are being created by the particular deployment. What is UDP is related to Kubernetes? Sultan, you will see in the Kubernetes networking concept, but where we are getting this UDP timeout while running pods, you won't be doing that, right? If you are using the persistent volumes in the Kubernetes YAML files, if those are not being created already, then the pod will not be created. That will be going into the pending state. Or if the particular image that you are mentioning, the image section of the Kubernetes specification, if the image is not existing, then you will get the crash to backup error or some kind of errors, because the image itself is not available. Then how the Kubernetes will or the Docker will create the container from that image? So those are some cases where the particular container won't be created because of some errors that also we will troubleshoot. So which one is using more? It is imperative approach or declarative approach. 100% we will use the declarative approach only. Imperative approach only few times we will be using. Okay. For example, declarative approach only we will be using most of the time. But commands we have to use, right? We have the declarative file, but in order to create the declarative objects from the declarative file, you will use the kubectl apply command. But declaratively, we won't do, imperatively, we won't do. Most of the time, we will use the declarative approach only. But you can use the imperative commands for the services which are created using the declarative deployment approach as well. Okay, that we can do. So please subscribe the course by end of the today. Please complete your payment formalities as well. Yeah, health checks will be there in the Kubernetes. That's why the health of the particular node is not good. Then we will get the status that the particular node is not ready. With that, we will be able to take the necessary action. Okay, guys, we are overshooting. We are running out of time. Yeah. Thank you very much. Please subscribe. Tomorrow onwards, regular classes will be started. Timings are 7 a.m. So please join the Telegram channel. There you will